Hi, my name is Nurul Zohana Alia binti Abdul Razak. My final year project is determination of heavy metal in whitening cream using inductively coupled plasma-optical emission spectrometry. My supervisor is Dr. Noraini Kasim. Cosmetics are defined by Association of Southeast Asian Nations as any substance or preparation intended to be placed in contact with the external part of the bodies. The cosmetic sector is rising rapidly around the world, especially in Malaysia. One of the cosmetic items that are targeted by people, especially women, is cosmetic that can whiten the skin. Skin whitening is termed to describe the process of lightening the tone of the skin through artificial techniques such as cream, lotion, soap, and injection. Whitening cream can treat skin disorders caused by solar exposure, age, low hormone level during pregnancy, or the intake of certain medicine. The constant and regular use of this whitening cream that have high contents of heavy metal may cause a bad impact to the consumers. It is because heavy metals become poisonous when the body is unable to metabolize them. Therefore, multiple cases have been issued by the Ministry of Health of Malaysia, MOH, as well as National Pharmaceutical Regulatory Agency, NPRA, about whitening cream containing harmful chemical. Even though MOH and NPRA have issued a warning not to consume this whitening cream, some individuals continue using them. The project will be helpful in providing information on the issues surrounding whitening cream that have a high content of heavy metal in Malaysia. For consumers, the result of this study will be able to help us find more suitable whitening creams with a low content of heavy metals. The objective of study to determine the presence of heavy metal in whitening cream through inductively coupled plasma atomic emission spectrometry, and to quantify the concentration of heavy metal in whitening creams using the calibration curve method. According to Tanwao et al. 2012, heavy metals are naturally found in nature elements with a large atomic weight and a density that at least 5 times greater than water. There are numerous manufacturing, residential, agronomic, medical, as well as technological applications have led to huge use in the environment. The quantity, weight of exposure, and chemical reaction, including the age, gender, genetic, and dietary pattern of exposure, may contribute to the toxicity of heavy metal. Heavy metals such as mercury, cadmium, arsenic, and lead are known to have their own unique features, uses, and potential for human exposure. According to Al-Kadami et al. 2013, 34 whitening creams were tested using inductively coupled plasma atomic emission spectroscopy to determine the presence of heavy metal. Arsenic, plumber, cadmium, and lead was discovered in all samples of whitening cream. Prakash and Manjushri in 2019 found that the various types of heavy metals such as copper, ferrum, and nickel in a sample of whitening cream of different brands that are commonly used in Bangla City using atomic absorption spectrometer. They had found the concentration of iron in the whitening cream was ranged below the detection limit. For cosmetic products in India are governed by the Drug and Cosmetic Act 1940 and rules in 1945, and labeling declaration are supervised by the Bureau of Indian Standards. The chemical used in this research were nitric acid 65%, hydrogen peroxide 30%, and deionized water. These chemicals were used in the sample preparation. The heavy metal was determined using an inductively coupled plasma-optical emission spectrometry (ICP-OES) Perkin-Elmer Optimal 2100 DV, Ohio, USA. The sample were gathered from different retail shops, drugstore, and beauty aid stores in Malaysia's local market. For this research, 5 samples of whitening cream products from local and international brands were used. These 5 brands of whitening cream were marked as brand V, brand W, brand X, brand Y, and brand Z, and every sample will be replicated 3 times. Aqueous stock solutions were prepared by using multi-element standard solution, Germany. The calibration curves were constructed by plotting the intensity versus concentration. The collected samples were digested using 65% HNO3 and 30% H2O2. This method was called as acid digestion process. 5 grams of each sample was carefully weighed and transferred into a flask and wet digest with 10 ml of each acid. Next, the samples were placed on hot plate with temperature set at 70 degrees Celsius for 1 to 2 hours or until the white fumes form. The sample were allowed to cool to room temperature once the acid digestion process done. Then, the sample were filtered using the Whitening filter paper number 42 and dilute up to 10 ml in calibrated flask with distilled water. Then, the samples were subject to the ICP-OES. For statistical analysis, the analysis were carried out in triplicates and the results were presented as mean and standard deviation. The statistical analysis were conducted using Microsoft Excel version 2016. Calibration curve graphs were generated using the WinLab 32 Windows software by plotting the intensity against the concentration of the standard solution. The calibration curve graphs of mercury, arsenic, lead and cadmium are shown in these figures. The linear calibration curve graphs were obtained with the linear regression equation obeying the Beer's law. This table shows linear regression equation, relative standard deviation (RSD), coefficient of determination (R²), limit of detection (LOD), and limit of quantification (LOQ) of the ICP-OES instrumentation. As shown in the table, the obtained linear regression equation has a R2 value range from 0.9909 to 0.9938. Indicate the performance of the data related to the instrument used in this analysis were very reliable. Moreover, percent of RSD values used for measuring the precision of the average replicates data or error percentage of mercury, arsenic, platinum and cadmium are very good. Table 4.2 shows the mean intensity of the heavy metal in this sample. Mercury was detected in 3 samples, brand V, brand Y and brand Z. On the other hand, lead was found in all the brands tested. Meanwhile, cadmium only found in brand Z. In contrast of other metals, the arsenic was not detected in all samples. From the analysis, it showed the majority of whitening cream product will add mercury in the composition since it was used as bleaching agent, while some of the brands use the lead and cadmium in the whitening cream since it acts as a colored pigment. The heavy metals amount were calculated from the intensity obtained from the above analysis. From table 4.3, brand Z contained 3 heavy metals, which were mercury, platinum and cadmium, followed by brand V and brand Y contain mercury and lead. Apart from these samples, brand W and brand X only contain lead compound. Hence, within all the samples, brand Z had the highest amount of mercury, brand W had the highest amount of lead, whereas only brand Z contained cadmium. Mercury was determined to be the most harmful of the heavy metal in this study. It can cause a variety of harmful impact on human health, including skin irritation, redness and burning, leading to mercury poisoning, skin cancer, kidney damage and fatal toxicity in pregnant women. Furthermore, unauthorized whitening cream had more mercury than the legal one, emphasizing the needs of properly monitoring in cosmetic product in circulation. In conclusion, from direct comparison, brand Z was the most dangerous whitening cream compared to others 4 brands because it contained the highest mercury concentration, and brand Z used 3 heavy metals compound as an ingredient, while brand V and brand Y contain 2 heavy metals, brand W and brand X only contain 1 heavy metal in the whitening cream. Hence, strict regulation should be enacted to limit or prohibit the import and local product follow the NPRA regulation in order to reduce the contamination. To improve this study, it is recommended to perform more testing to improve the performance of ICP-OES. In addition, this method can also assist in obtaining more accurate and precise data. Hopefully, this study will encourage further researchers to employ ICP-OES to detect heavy metal compounds because ICP-OES is an excellent method for determining analyte at low concentration, allowing evaluation of harmful and dangerous compounds in cosmetics since it can be used to measure almost all the elements in the periodic table.